Together with Maren and Kelly, we're going to be talking about integrating agile methods into medical device software development. Quick summary of my background. I'm a consultant. I've been working in medical device product development for 20 years on a wide range of technologies and everything from very simple products to very complex ones. I help my clients with risk management and design controls and incorporating lean and agile methods into their product development. Maren and Kelly and I are going to be giving a brief description of Agile, the benefits of Agile, and the issues of regulatory compliance for a medical device company adopting Agile and the general challenges of making the transition. And then the rest of this session will be answering questions from the audience. Before I get started, I'd just like to do a quick survey of the audience because we have quite a variety of backgrounds here. Please raise your right hand proportional to how much your company has incorporated Agile or uses Agile. Fully in, sort of, not at all. And then keep your hand up and use your left hand to indicate how successful, total home run or total failure, something in between. Okay, so we have the full range of all the permutations, and that should make for some interesting questions at the end of the session. So let me start by explaining what is Agile. There are many different definitions for the purpose of our presentation. I'm going to first emphasize Agile is not a recipe. So if someone comes to you with a step-by-step recipe to how to magically transform your organization to become Agile, you should be very suspicious. That's not how it works. So Agile is a framework, and it is a principles and practices used by collaborative teams. And the team part of Agile is very important. Strong teams are crucial to a successful Agile implementation that rapidly and frequently deliver customer-valued software to meet business needs. And for a medical device company, crucially, that includes regulatory compliance. So Agile methods began in the 1990s. In 2001, a bunch of software gurus got together and declared what is called the Agile Manifesto. And briefly, they stated, we've come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. Now, this was met enthusiastically by many software engineers, but it presents some real issues for a medical device company. In a heavily regulated environment, processes are very important to us. Documentation is definitely important to us. Contracts and plans are definitely important for regulatory compliance. So how does a medical device company square these two very different worlds? So really the key thing here is balancing out the benefits of Agile methods with the necessity of regulatory compliance. Fortunately, there's an excellent guidance called AMI TIR 45, and Kelly's going to be talking more about that in just a moment. Agile has 12 principles. I won't read through them, but just by scanning some of the words in there about satisfying customers, about motivated teams, face-to-face conversations, technical excellence, these are all things that align very well with a quality system. There's nothing in conflict with what you want for a well-run organization producing high-quality products. Now, I said Agile is both principles and practices. The practice that's most commonly associated with Agile is the Scrum method. So this is an illustration of Scrum. If a software development team is given 10 months to develop a new application, using the Scrum method, they take those 10 months and they slice them into small increments of 2 to 4 weeks. These are called sprints. At the beginning of each sprint, the team gets together to plan the work they're going to do over that short period. They execute to that plan with daily tracking of their progress and issues. At the end of the sprint, they're able to deliver working software to the rest of the organization to evaluate and get feedback on. This is This is a simple method, but it has powerful implications for software development and for product development overall for the company. Agile has been adopted by many different industries. It's become very popular. You can read online. There's tons of resources about it. Has many different benefits, better flexibility, more predictability of software releases, better visibility of software progress, increased flexibility, and most importantly for medical device companies, improved quality of released software. There's other benefits as well. Uncovering hidden requirements, that's often a gotcha for a lot of product development through early evaluation and early integrations, early and frequent software verification, finding software bugs early and often, and avoiding unnecessary and unneeded code in the final application. Now I'm going to turn that over to Kelly, and he's going to be talking about issues of regulatory compliance with adopting Agile.
So hi everybody, I'm Kelly Wyrock. I was a long time in the software organization at Medtronic where we brought Agile software development to our software organization. And in that time I worked with the FDA and an industry committee through AAMI to create TIR 45, a guidance on how to provide how to make Agile software development work with the medical device world and integrate with the regulatory expectations. We'll talk a little bit more about that. So the first question that many medical device companies say is, what does the FDA think about Agile? Agile provides a different model for how to do development. It's a different life cycle model of how activities are organized together and how software is delivered. And the regulatory guidance clearly states that there is no preferred model from the FDA. Many organizations assume that FDA has a more conservative approach where they encourage more linear methods, traditional software development methods, but that's not the case. The guidance documents make it clear that manufacturers own the definition of their process and the model that they use to develop products in general, as long as it meets regulatory expectations. So a way to align with that, the AAMI Software Committee kicked off a subcommittee to create guidance to provide instruction to industry and regulators of how the Agile method applies. Some of the things that brought concerns with the Agile model related to the life cycle of how activities are organized, the degree of documentation that's produced, when documentation is produced, things that the team members decide how to develop software as the software evolves, were all concepts that were uncomfortable in the regulatory space. So this guidance document gives recommendations of how to align the Agile model with regulatory expectations. It was created through a committee that included industry representatives and the FDA. Experts from the software organizations within the FDA participated in creating the TIR. The fact is Agile is not incompatible with regulations. As I mentioned, it's quite clear in the regulations and guidances that it's up to manufacturers to pick their development process. We own defining what the systems ought to be, what the process ought to be. But it does often conflict with organizations' own company policies. SOPs are often written to assume a linear sequential development model. Sometimes they specify exact documents that have to be produced. Sometimes they specify how different teams and organizational structures must work to create those documents and do their development activities. So the Agile model needs to be aligned with the SOPs, with your standard practices. Sometimes your processes need to change, and sometimes Agile needs to change to adapt together. So the FDA made it very clear in the creation of the TIR that Agile models make sense if applied well. The common reminder we were given is the design control regulation is intended to provide controls on a process. It is not the definition of the process. So the Agile model is a way to define a software development process, and the expectation is we demonstrate how design controls exist in that model. So how would FDA respond to an organization that's using Agile development techniques? And the answer is it depends on who you ask. The FDA representatives on the committee, as we were creating TIR 45, sent a draft out to their colleagues for comments, and we didn't get a lot back. And when they pushed forward to say, why aren't we getting comments back, what we heard from the regulatory submissions side of the FDA is, we really don't need to care about this. We want to know that you've got a good process in place and that you produce good evidence at the end, but we care a lot less about the path you take to get there. So in a regulatory submission, it's often not even necessary to talk about the use of Agile methods. If, however, the FDA is coming in for an investigation, it'll depend on what they're looking at. If they want to dive deeply into your development processes, they will certainly see how Agile is applied. If they're coming in to diagnose a problem, Agile becomes visible if it's the problem, like anything else in your development environment, or it might become visible as a way to address some of the problems that organizations already know about in their development process. One key point I want to highlight from the TIR is related to the linear models that are prevalent in software development and product development in general. We often think of linear models where you start with inputs. You define your requirements, you then define your design, you then define your tests, and you execute those tests. It's a very common linear model. What the TIR points out is there's a strong overlap between what FDA regulations talk about design inputs and design outputs. We all recognize and accept that inputs need to come before outputs, but what does come before really mean? Some organizations interpret that to mean the requirements need to be written, approved, and locked down before we proceed to design. But I don't know any development organization that works that way. I dare you to stop a development engineer from thinking about a solution as soon as you've given them an idea of what the requirement might be. What happens is we think about the inputs, and then we start thinking about what the outputs could be. We decide when we need to write down those inputs, when we need to write down the outputs. We decide when we need to formalize them, and that can occur in a very complex, interchanging way depending on the need of the problem at hand. What the Agile model highlights is it's not the path that you take to get there that matters, it's the fact that you end up with an organized set of things at the end, that the inputs match the outputs, regardless of the order you took to write them down or approve them. The Agile model takes that a little bit further to say that this interchanging interrelationship between inputs and outputs happens all the time at small levels. The Agile model emphasizes delivering small pieces of value frequently. The worry with that model is we develop the small pieces, but the parts don't come together. So the TIR talks about synchronization points where we align the inputs and outputs to see that we are in control of the development process as we go. So the quality system gets satisfied in an Agile model just slightly different than the traditional linear models. Sometimes we satisfy it as we're creating the backlog of work to be done. Sometimes we satisfy the quality system little bits at a time. Sometimes we satisfy it large bits at a time. And the guidance of the TIR 45 talks about how to do that in practice. Okay, I'm going to turn it over to Marin for the next piece.
Good morning. There we are. So I'm Marin Nelson. I worked with Kelly during the time that Medtronic was going over to the Agile systems. I also did a fair amount of medical product development up in the Seattle area, and I still consult in that area. There we go. So Kelly talked about the FDA and the regulatory aspects of working with the FDA. I want to talk a little bit about one of the other major regulatory areas that we often deal with, which is the EU. If you do software development, you may have heard of the 62304 software standard. I'm going to advance here so I can see what I'm talking about. The 62304 software standard is not a standalone, it doesn't stand alone. It works in harmonization with the 13485 standard to define the specifics around software development for medical devices. So the 62304 works well with both the 13485 and with the 14971, the risk management procedure. So what does that actually look like if you're going to put it in kind of an overall picture? As you can see here, the software, the overall process is in the grayer box at the top. The pieces of the software standard exist underneath that. Those pieces, which are way too small to read on the slide, are the traditional things that we think of in terms of planning and design inputs, design outputs, design review, design verification, all the pieces that you normally go through within a software process. That is laid out here as well in this really nice color-coded map that shows the activities. Planning is laid out across the top, and then we have the requirements analysis, the architecture design, detailed design, implementation and verification, integration, as Kelly mentioned earlier, that's a very important part of the 62304. Then system testing, which is a higher level of integration, and then finally you get to the point where your software release is ready to go. So the planning or the activities are done incrementally. You start with stories or with the individual activities. Each of those then roll up into a sprint. Each of those would roll up into an increment or a release, and then finally you get to the point where you're a product. So you run through this process over and over again. That's the iterative part of Agile. On each of those activities, those little activities, you do the full range of the pieces that we've talked about. And to me, this is one of the really powerful areas of Agile. As Kelly mentioned, most organizations do product development incrementally. You start and you do a piece of the software, you do a piece of the hardware. Agile emphasizes finishing each of those activities as you go through it. So when you finish a sprint, when you finish a story, you know that the software is working, you know that it's meeting your requirements, you have a complete activity. Not that theoretically you've implemented some software, it sort of looks like it works, and then you move on to the next piece and it sort of looks like it works. And then 6 months later you find out that it really didn't work in that first level of iteration that you did. So to talk about the two areas that to me are key in Agile, planning is one I mentioned. So planning, again, you plan around a story, you plan around a sprint, and you plan around a release for a particular feature perhaps, and then you plan around for the product. So the design controls, going back to the FDA, are the design controls for the product are organized around these multiple layers. The other key piece for me is design change, which is part of 62304. Each of these incremental activities that you do is treated as a design change. So each change will bring in the new requirements, but you're also checking to make sure what you did previously is still working. So how do you implement Agile in your organization? This is a change. Right? We could do a whole long session on how do you do change management in organizations. But basically, first of all, you need to identify the problem that you want to solve. You want to determine what the possible solutions are, and we're encouraging you to think of Agile as one of those possible solutions. You want to make the changes in small steps. There's some really good information out there, as we've discussed in both TIR 45 and in 62304 about these changes that have been made by others. You want to make sure that you set organization expectations that there will be time to train. Every time you roll out a new process or a new way of doing things, it takes a while for people to get familiar with it, and that's an expectation to set up front. And then you want to make the benefits visible to the organization. For folks who are engineers like me, this is often the hardest part of doing a change because you don't like to toot your own horn or say, hey, look at all this great stuff we did. But if you don't make the benefits visible to the organization, nobody knows, and the effort will eventually go away. So if you're bringing Agile in, you're affecting the product development process. As we've seen in the previous information, the product development process is bigger than the Agile software development aspects of it. So defining what the problem is first is key, because Agile is not going to fix all of the problems within a product development process. So how do you implement Agile? Specifically, you identify where Agile can help most. We had a discussion this morning at breakfast where somebody mentioned that they use risk management and risk assessment in doing their development planning. Maybe you use this idea of incremental planning to focus on the risks that are highest in your product development process or in your product implementation, and you work those through as you do it first. Maybe you have another way. Maybe there is a marketing, or there's an aspect of the user interface that you need to set up first, and that will be your area. So as you do your incremental planning, be very mindful of how you're identifying the priorities and the criteria. So make it an approachable transition. We've already started this process for you today by talking about Agile and by giving you the language to go back to your organizations and talk about how it is compatible with regulatory approaches in many places. Most of you probably already use iteration in their product development process. As Kelly mentioned, engineers start thinking about the solution as soon as they know what the requirements are. And the lower you can make that step, the easier transition is. Integration will involve, again, all of the design control activities. The power with this approach is that you're not just doing code, you're including the risk analysis, you're including the requirements, you're including the verification. And if you think of this as, am I or am I not agile? It's a little more daunting. If you think about your organization becoming more agile, it gives you a path to moving forward. Am I there? There. So in summary, you can use agile methods for medical devices, and there are many companies that are doing that now. You should use agile methods for medical devices. It's actually much more in line with the way we do implementation in terms of thinking about things iteratively. And it gives you a faster response to when you have software problems in the field. And implementation does not require you to be a superhero. You can bring this to your organization in a way that you can present it iteratively and take it in small steps.
Thank you, Maren, and Kelly, and Aaron, of course. We have time for questions. The first one is mine, and that is, I understand that Agile can be intimidating for someone to start right off the bat. For those medical device companies that have both a hardware component and a software component, where would you have them start? How would you have them integrate? Is it part of the same process where everyone comes together, or do the hardware engineers stay here, the software ones stay there, and they meet somewhere in the middle? If you could comment on that, any one of you.
As always, for questions like that, the answer is it depends, and it depends on the need of the organization. It depends on what problem they're trying to solve. Agile's sweet spot is software development, so it makes sense to start there since many of the practices fit well with software development, but now there are many organizations using it to develop hardware. So if the difficulties the organization is having is getting an entire system out, the incremental model of Agile can help throughout the system. If their system is well decomposed into components, subsystems like software can be delivered separately, it might make sense to start with just a software team. So it depends on what problem you're trying to solve, how big the problem is that you're trying to solve, and how big of a transition it might be.
So I will add one thing to that. Totally agree with Kelly on how this is implemented. But if you're trying to integrate between the software and the hardware team, that to me is a prime area that you use for identifying what the focus of a sprint is. So if your hardware team is getting a prototype back and they need software from you to support that, that becomes part of one of those small planning cycles, and you make that a priority in how you lay things out.
Okay.
I'm Jahnavi Lokre from Spartan Corporation, and I just wanted to add to the discussion. We have started to experiment with trying to use Agile for hardware systems, and as you said, it clearly depends on the need of the project, but one of the biggest benefits of Agile that we have found is to be able to get client feedback early on in the process. And as a contract design firm, that's really important to make sure that we're developing the right product for the client. And we have used techniques like using evaluation boards for hardware and quick prototyping with 3D printing and what have you. Those type of techniques to do sort of these shorter sprints for Agile for the whole system, not just for the software. Any additional tips that you might have to help us with that process?
We're working with the hardware world, electrical and mechanical hardware. One of the things that's resonated with some of my clients is to think about the decisions that you need to make, the progress that you want to demonstrate. So sometimes the incremental delivery of value is not working product, as the manifesto talks about working software. It's value that you've delivered to somebody. And one form of value is a decision. We made a decision about something with this mechanical piece that we are now ready to move on. An example was we made a decision on the finish of the part so that we could begin qualifying vendors. So we did the work necessary to make that decision, even though the rest of the part was not yet designed. So it's about identifying where you need to make decisions to deliver value to keep the process moving.
So in terms of applying agile methods to hardware, don't allow software ideologues to say you must do this 2-week cadence. And one of the things to think about is that in development, when we talk about these iterations, we're talking about design, build, test. And in software, as Kelly said, that can work very rapidly. So you have a lot of flexibility about how quickly you can deliver working software. Hardware engineers don't always have that same flexibility. So a mechanical designer, there may be a 6-week wait to get the components for a new assembly that he or she has designed. And you have to take that into account if you're trying to apply those iterative approaches to your hardware. So don't blindly assign a 2-week or 3-week increment to hardware iterations. Do iterations that make sense for the type of product and the technology, and particularly the time it takes for design, build, test cycles.
Hi, Tim Hughes. Can you comment on your consulting experiences working with large companies and their culture and their size and how that impacts their ability to rapidly adopt an agile process?
With any large company, it's all about the change management. So my best experiences have been, first of all, clearly identifying the problem up front so that you can show progress or show the results at the end. Because anytime you can give a concrete, yes, this saved you, 4 weeks of time, or we were able to implement twice as many features in the product as we thought we could, is a good thing. Sometimes if you're doing a change project, it's a little bit easier to measure. If you're adding a software feature to something, there's not as many uncontrolled variables with all the other parts of product development. So as much as you can isolate, here's what the software change is, especially if it's similar to a change that was done earlier, gives you the chance to show those metrics. It's all about the planning and then making sure you do that.
Hi, I'm Jorg with Perriman Corporation. How does risk management fit into the whole agile process?
I'm sorry, fit into the which process?
Agile process, the risk management piece of the development.
I will talk about how I usually approach it and then let Kelly and Aaron jump in too. Risk management is something which, like planning, goes through the entire software design process. So from my perspective, as soon as you have requirements for software, as soon as you're actually writing software, you can start the risk management process. So if you have implemented a certain functionality within a sprint, you've also done the risk management, looked at what risks you have in that software operation, and hopefully implemented those mitigations as you go through. So by the time you get to the end, you've not only got the verification suite, but you also have done the risk management.
I'll add that the planning mechanisms of Agile talk about creating a backlog of value to be delivered, and we burn down that value by delivering. Many teams also have a risk burn down, where on the backlog we annotate where the risk elements are, and that's a factor into describing the order of the backlog so that we identify which risks we have to do something to mitigate, which risks are we willing to defer until we have more knowledge to mitigate them. So it's integrated in the planning process as one of the factors to determine the order of activities.
One more thing. So, and just to make it clear in terms of, I work often with product development teams on risk analysis, and it's it's anti-agile, if you will, to leave that to the end. So agile methods are not an excuse to put off documentation until after we've done development. That's both contrary to the design control regulations and contrary to good product development.
Hi guys, Scott Thielman from Product Creation Studio. One of our, the guy who was developing our project management principles at PCS has an example where he says, you know, if Lewis and Clark had used waterfall, they'd still be planning. If they'd used agile, they probably would have run out and all be killed. And if they had used something in between, what he calls an adaptive approach, they would have done enough planning, but also being ready for the change. And I was wondering if that's totally fair. I think a key thing that, Aaron, you hit upon was that, and we deal with hardware development mostly, is that those increments can't be, in hardware, can't be mandated quite so rigidly. We might have that a couple of months to plan and get the first hardware development system, but now our build, test, and learn cycles, maybe that can go down to a couple of days where we're trying something quickly for a while. So I just want your perspective on you know, is that fair, and maybe a little more illuminating on the sprint timelines.
So in terms of the length of a sprint and changing it for hardware development versus software development, I'll just say that that one of the advantages of the Scrum method is a cadence, whether it's 2 weeks or 4 weeks, and a lot of sort of interfaces with the rest of the organization can be built on that, and it simplifies a lot of the work for the engineers involved in it. So if you're varying the length of the sprint, you're not getting the advantage of that cadence. That said, for hardware, there may be cases where it just doesn't make sense to have a bunch of small sprints, and it might be advantageous to not call them sprints, but to call them, I've seen them called learning cycles or design iterations, but in particular to make sure that you're tailoring them in a way that makes sense to the limitations of that particular technology.
Hi, I'm sorry.
Sorry. I wanted to actually comment, because I think the idea that with Agile you just push forward and put stuff out even if it's not good is probably misbranding for Agile. The idea behind Agile is that you are pushing forward to get decisions made to get to completeness, right? That idea of periodic completeness is really key. If you don't finish all the activities that you need to in the sprint, you have accumulated the technical debt that Kelly was talking about earlier. But just because you're using Agile doesn't give you an excuse not to do a complete product development activity appropriate for the product you're looking at.
I'm just curious. I'm Dan Golka, MedTech Directory. Just curious, if you have a lot of small companies could implement this together, but if you had a large company like Spartan and one team wanted to implement this Agile process, how have you seen that implemented and how that compares to, I just want to say, a regular workforce and how the projects evolve?
I think a lot of companies start out with a small proto product or a pilot project or something. They don't switch over wholesale. That's part of the change management process, is figuring out how you take it in small steps. As Kelly mentioned, a lot of times the company processes will focus on a waterfall method, not an iterative method like this. My tool has always been to use a project plan, to say, with this project plan, we're going to deviate from our current processes, or we're going to modify our current processes to try this approach. Project plans in medical organizations are typically signed off by the quality organization, so the plan is one of the quickest tools that I know of to adjust a process to try something new.
So the Scrum method of Agile really focuses on the small team delivering value, but scaling models have been around for a long time. How you scale Agile in an organization you have multiple teams working on multiple elements of a system. The key element to that, with whatever method you use, is how you architect the development teams related to the architecture of your system and how you're going to build it. And as with any architecture, it's the interfaces that determine the success of it. So identifying where the alignment points are, how we can can allocate work and let teams run independently, when they have to align together, is key to those models of any big system, any big organization, whether all teams are agile or not. You have that same problem. How do you integrate in the line?
My name is Daniel. I want to thank your team for the wonderful presentation. Well, I was just wondering, I saw Lean there, and I was wondering if it's the same thing with Lean Six Sigma, as not much emphasis was laid on it in your presentation.
Yeah, agile methods are built off of lean concepts. Agile didn't invent a lot of these things. It's how they put things together. So there are many elements of Agile that embrace lean, such as small batch size. That's why the increments are small. Eliminating wait times, which is why we get to done. Making decisions at the last responsible moment. Decide when you need to make decisions and when you can defer things to leave flexibility. These are all lean principles that have been around in lean manufacturing and lean development for a long time, and Agile embraces them well.
However, Six Sigma practitioners often will be in conflict with Agile methods. And I'll say in general, a lot of organizations find Agile methods alarming or unnerving because they think development teams are out of control. So when we talk about an approach of sort of piloting and limited initial usage to gain confidence in the organization, it's partly to reassure people who would be very uncomfortable with this unusual way of developing product. And not to oversimplify, but Six Sigma practitioners, many of them will feel quite uncomfortable with a highly iterative approach that doesn't have all the kinds of upfront planning that they're accustomed to.
Aria Halpern, question to ask you. So with the Agile approach to software development, and then you look on the other side with model-based systems engineering approach with RFLP. So is there then a convergence between Agile and model-based systems engineering approach in terms of addressing partly the software design element that fits within the typical V diagram of RFLP?
Speak to that. Yeah, that's a hot topic in the INCOSE world. If you're familiar with INCOSE, the International Congress on Systems Engineering, I'm on the organizing committee for a conference coming up here in May that's addressing the integration of systems engineering principles and Agile methods. And model-based techniques are very much in line with the Agile model, allowing you to do things iteratively, allowing you to make decisions in increments, deliver value in pieces, even if it means you can't deliver the final solution for a long time. So there's a nice overlap between those two. Yes, that's right. So it's in Chicago in May 16th, 17th. Talk to me afterwards if you want to hear more about that. And also the AMI organization has 2 courses related to TIR 45. One is specific to the TIR and the application in software. And there's another course on applying the concepts in the development of a medical device system that includes software and hardware components. And we talk about those model-based techniques in that course as well.
Hi, I'm Rick Stockton. Is there a reference, for instance, a tabular reference, which could illustrate succinctly the difference between, say, Six Sigma application systems and Agile systems? Because Six Sigma is something that I deal with a lot with the people that I work with, but what you're describing would work a lot better for their projects, I think. But I'm trying to describe it.
I'm not aware of a reference like that. It would certainly be useful and would probably help to improve communication between people from different backgrounds and different philosophies. I mean, ultimately, we want to create excellent medical products. There are multiple methods to do that. Agile gives you sort of a suite of tools as well as principles to guide development. But it doesn't mean that it's the only methods that you can use.
Well, from the caliber and the number of questions, you really hit on a nerve here. So thank you for sharing your knowledge with us. Aaron, Kelly, and Marin, thank you.